Yesterday, we have discussed regarding procedural assignments. So, in this procedural assignments, we have considered blocking statement as well as non-blocking statement. In case of blocking statement, what we can able to observe is here until the complete execution, the corresponding statement has to uh, wait for means the next statements has to wait until the complete execution of the current statement. So that is what it happens in blocking assignment. When there are any delay, the statements after the current statement has to wait till the complete execution. But in case of non-blocking assignments, what happens is it's need not necessary to wait until the execution of current statement. It will initialize and then it will go for the next statement. Means scheduling, when the complete execution has to be done, it will be scheduled, but it will not block the next statements. So immediately after initializing, it will go for the next statement in case of non-blocking statement. One of the advantage in case of non-blocking is whenever there is a race condition in blocking assignment, there we can eliminate the race condition using non-blocking assignment. So here we can observe that there are two always statements. In one always statement, a is equal to b, and in the another always statement, b is equal to a. During every positive edge of the clock cycle, both the statements will be active. When both are active, simulator at a time it cannot execute, so it will more than one statement, so it will execute only one statement at a time. Either it may execute this first or it may execute this first. While executing, the values will be read and assigned. So as a result, there will we cannot able to exchange the content of a and b if I'm using a blocking assignment. But when I'm using a non-blocking assignment, what happens is, as soon as the positive edge of the clock occurs, both the statements will going to read the data. After reading the data, what happens is, they will going to assign later, but already the data has been read, and if this executes first, whatever the previous data of b was read, that will be assigned, and afterwards this will going to execute according to that. Here what happens is, we will going to get the, and here in this case what happens is, we are going to get the output of that is b will be equal to the value of a. Even though the value of a has been changed here, it will going to take the previous value. As I told, during the positive edge, the value of clock has positive edge of the clock, the value of a has been already read. So that is why it will going to assign previous value only, current value will not be assigned. Okay. Now, if we want to eliminate race around condition without non-blocking statement, in that case, what we can able to do is, during positive edge of the clock, if I mention temporary variable a is equal to content of a, and similarly temporary variable of b is equal to content of b, and afterwards I'm executing a is equal to temp b and b is equal to temp a. Here what happens, first this statement will be executed, so the previous value present in a will be stored in a temporary variable, and similarly when executing this statement, the previous value of b will be copied to temporary variable. Now we can exchange the content of a and b. So what I'll do, I'll going to execute the third statement. A is equal to temp b. Temp b is having the previous value of b, so that will be stored in a. And now here temp a will be having the previous value of A, and that will be stored in B. According to that, we can able to do exchange. For example, let A is equal to 0 and B is equal to 1. Okay. When A is equal to 0 and B is equal to 1, during the positive edge of the clock cycle, first the temp A will be assigned with the value, let me represent TA will be assigned with the value A. What is the value present in A? It is 0. Similarly, the temp B will be assigned with the value present in B. So, what is the value present in B? It is nothing but 1. Afterwards, the third statement is executed. So, now what I am writing? A is equal to temp B. So, the value present in temp B is equal to 1. So, now A will get the value 1. Similarly, B is equal to temp A. Since the value present in temp A is 0, so this will going to get the value 0. So now we can able to observe that the value of A and B has been exchanged. Okay, so it indicates that these previous values are stored in a temporary variable and then it has been exchanged. The similar operator the non-blocking statement will going to do. In case of non-blocking statement, what happens? First only it will read the value and store in some temporary variable where the designer cannot able to access. Okay. After storing in the temporary variable, then whenever the statement executes, that will be copied. So this is similar to the non-blocking assignment using a temporary variable. And usually we are not going to use non-blocking assignment because it will going to consume more memory, because here only we can observe that for these two statements it will going to use two memory locations where the initial value of B will be stored and again the initial value of A will be stored, and then while executing this the initial values are considered. So as a result, till the execution of this statement the data should be saved in the memory, so it will going to consume more memory compared to the blocking statement. That is why typically we are not going to use more non-blocking assignments while modeling. Usually we are going to use blocking assignment only. Okay. Because of that, the simulator performance will be reduced as it uses more and more memory. If we consider the larger program, in such case, there will be increase in the memory usage and we cannot able to get better performance by the simulator. Next, what we are having is timing control. When we are going to consider timing control, here in a simulation, as soon as we give the input, immediately we'll get the output. But when I consider a practical circuit, because we are writing program for the practical device, isn't it? So when we consider a practical circuit, there will be a delay associated with each element present in the circuit. As a result, what happens to perform addition operation or to perform multiplication or division operation? In such case, it will be having its own circuit and each circuit will be having its own delay. So, while writing the program, we have to estimate that at least the particular circuit, it may take this much amount of delay. In such case, what could be the output? So when we are able to analyze with the delay, then we can able to get more and more practical circuit implementation. Otherwise, if we do not consider delay, what happens is without delay we can execute and we can get output in the simulator, but practically some of the devices in the entire circuit, some of the devices may have maximum delay and some may have minimum delay. In such case, proper data will not be propagated between each elements. As a result, we may not get the correct output. So, in order to get the correct output, we have to consider the delay associated with each operation. In order to mention the delay, we are going to use timing control. And also, sometimes, whenever a particular task or whenever a particular situation occurs, then a corresponding work has to be done. So, in such case, what we are going to do means we will going to consider event based. Event based means, see, when there is an event, then only there will be a change of state. Otherwise, if there is no change in the state means it indicates that no event has occurred. So that is why there is no change in the state. For example, if we consider a cup of water, then it will be having the same property. Okay, whenever you are going to add an extra element like salt, or if you are going to add sugar, then the property of the water will going to change, isn't it? So the property of the water is changing means some event has occurred, that is adding a salt or sugar for the water. That process is known as event occurring. When that event occurs, then only the property of the property of water will going to change. In the same way, if I consider in terms of signal or value, if any event occurs, then only the value can change. Otherwise, the value cannot change. So that is called as event occurring. So identifying the occurrence of event, and how we can able to identify the occurrence of event, we will not be knowing how actually the event will going to occur, but we can able to notice what could be the change in the signal whenever an event occurs. So based on that, we will observe the change in the information. So whenever there is a change in the signal, in that case we will consider that some event has occurred. So that is why the value in the signal has been changed. Based on that change, the corresponding operation has to be done. So that is known as event based time control. And delay based time control means, as I told, every device will be having its own delay. So while executing any particular function or any particular uh, process, in that case we will going to mention it should take this much amount of delay. That is known as delay based time control. And one more thing is level based time control. For example, what example we can consider is, best example is latch. Whenever I am going to consider latch, so if I consider d latch, let me consider, we are going to consider d latch. So what this d latch will going to do, it is having two outputs, q as well as q bar, and two inputs, one is d and the another one is enable. Okay, as long as enable is high, in that case whatever the data you are going to place in d, that will be assigned to q. Okay, but when the enable becomes 0, when the enable value becomes 0, in that case, even though if the value of d changes, the value of q will not going to change. That indicates that we are identifying a constant value logic 1 in enable pin. So that indicates a particular level in the clock signal or in the enable signal. If you assume that enable can hold either 0 or 1, only these two values. So in such case, I need to identify this particular level. When this particular level is there, then the corresponding operation has to be done. So that is why it is known as level sensitivity timing control. Like this, we are going to consider three different types of timing control: delay based, event based, and level based. So, first, let me consider the first timing control, that is delay based timing control. In case of delay based timing control, what we are going to do is we are going to mention the delay. So while mentioning the delay, this is the general syntax we are going to use. First, we will going to mention the delay and then the corresponding variable name. After the assignment operator, we are going to write the expression. Again, in case of delay based timing control, there are three types of delays. One is regular delay, intra assignment delay, and the another one is zero delay. Regular delay means first we will going to mention the delay and then we will going to write the corresponding statement. That is known as regular delay. It means the usual notation what we are going to follow. And this is one of the example what we are considering. Here we can see that we have defined a parameter latency. Latency is assigned with a value 20. Whenever we want to represent 20, in that case we can use the name as latency. So always latency will be having a given value. And similarly we are having delta, that is equal to 2. Small changes, usually small changes we are going to call it as delta, right? So that delta will be given by assigned by the parameter and its value is equal to 2. So now how we can able to represent the delay means either I can able to represent using a number, or I can able to represent using a parameter, or I can able to represent using a expression, or by using a variable, or by using minimum, typical and maximum delay. These are the different ways of representing the delay. Okay, here have just given a number as 10 y. So what it will do, it will wait for 10 time units and afterwards the value 1 will be assigned to y. And here what I have mentioned is latency. So when I am going to consider latency, latency is having the value 20. So after executing the second statement, it has to wait for another 20 time units and then 0 will be assigned to z. Similarly here I am using a plus operator which is having two operands, latency and delta. Latency is 20, delta is 2. So it will add these two. So after this statement, it will wait for 22 time units and then 1 will be assigned to P. Similarly here we are going to consider y is equal, so in this what we are considering is we are having y is the variable and what is the value present in y? The value present in y is equal to 1. So that is why it will wait for one time unit of delay and then it will execute this statement. And the next thing, the minimum, typical and maximum. This we have discussed while we have considered gate delays. So what is the minimum delay it has to consider? The simulator. And similarly, what is the typical delay it has to take? And then what is the maximum delay it can consider? So like this, we can able to represent regular delay. Next, what we are having is intra-assignment delay. So what this intra-assignment delay, how it is different from the regular delay means, here without delay I am assigning x equals 0 and z equals 0. But while considering y, I have mentioned y is equal to ash 5 x plus z. So what this ash 5 indicates, it has to wait and then it has to assign. Means first only it will compute the value of x plus z. But it will wait for 5 time units and then it will assign. Previously, if I am going to mention ash 5 y is equal to x plus z. So in this case, what happens? It will wait for 5 time units of delay and then it has to calculate this and assign. But here, first only it will calculate and then it will wait and then it will assign. That is the difference. So that is why here it has been mentioned. Take value of x and z at time 0, evaluate x plus z and then wait for specified delay and afterwards assign. So for assigning it will take the delay, not for computing. But here for computing only it will take the delay, means first it will take the delay, later it will compute. That is the difference. Okay, this is regarding intra assignment delay. And next, this is one of the example in which what we have it is similar to the intra assignment delay. So here what happens, first it will going to compute x plus z and it will store in a temporary variable, and after the specified delay it will assign. Either we can write like this or we can write like this, both will do the same operation. Okay, and next what we are having is the difference between the corresponding intra assignment and regular delay. As I told, in case of regular delay, first it will take the delay and then it will execute later assignment. But here in intra assignment, first it will execute, then it will wait, and then it will assign. Okay, this is the main difference. And next what we are having is zero delay. Why we are going to consider zero delay means, here you might have seen the statements. I have mentioned x equals 0, z equals 0, then y is equal to ash 5 x plus z, isn't it? All these statements were executed, and before coming out of the statement assignment will be done. Okay, as a result what happens is, while more than one statement is there, which one should be assigned first? Okay, so that we cannot able to determine. Again it depends upon the simulator whether it may assign this value first or it may assign this value first. It depends on the simulator. But while assigning, we can mention which one can be assigned at the last, not at the first, but we can mention which one should be assigned at the end. How we can able to mention means by using the zero delay. Okay, whenever I am going to mention the zero delay, after assigning for all the statements, it will assign for a statement which is having the delay 0. Here you can see the example. So in this, I have mentioned initial begin x equals 0 and y equals 0 end. And afterwards, I have mentioned ash 0 x equals 1 and ash 0 y is equal to 1. Okay, while assigning, what it will going to do? First, x equals 0, y equals 0, it will assign. After assigning that, then later it will assign x equals 1 and y equals 1. Means at the end of the simulation time, it will going to assign. Since here the end of the assignment time is 0, so by the end of the 0th time, it will going to assign. That is what we are going to consider it as 0. For example, if I am going to tell that we have to execute this particular program within 5 minutes, okay, in such case what we are going to do, we will going to consider the time till 4 minutes 59 seconds, like this we are going to consider, isn't it? And at the end, after 59 second, we are going to get 5 minutes, right? That is the end of the time. In the same way, by the end of the 0th time, it will going to assign when I mention delay 0. Okay, and next, what we are having is event based time control. When we are going to consider event based time control, so in that case, again, we are having 4 different types of time control, that is regular event control, named event control, and then we are having or event control, and then level sensitive timing control. So here Mainly, when we are going to consider this event control, in case of event means the value has to change. So the value is changing means something might have happened. That is why the value is changing. So according to that, we will going to consider regular event, named event or and level sensitivity. So first let me consider regular event. Regular event means as soon as the change occurs, it is identified by the symbol at. Whenever you are going to identify mention the symbol at, what it will do, it will keep on monitoring the specific signal. Immediately as soon as the value changes, it will recognize. In this example we can see at clock I have mentioned. I have not mentioned which edge, but simply I have mentioned at clock. So whenever the value of clock changes, immediately it will recognize, and by that time the value of d will be assigned to q, whether it may be positive edge or negative edge, whatever may be the edge, but it will assign the value q at this particular time. And suppose if I want to consider only during positive edge, then I have to mention at positive edge of clock. So whenever the positive edge is identified, then this operation has to be done. Till then, it should not do. Okay, here I am not mentioning ash 5. Ash 5, what it indicates? It has to wait for 5 time units and then it has to assign. But here, what I am doing? I am checking whether a clock signal changes or not. The clock signal may change at 5 time units, or it may change at 10 time units, or it may change at 30 time units. Whenever the change happens, then it has to check whether the change is a positive edge or not. If it is a positive edge, then assign q is equal to d. Otherwise, it won't assign. Similarly, I can consider for negative edge. This is somewhat regular assignment we are doing. Similarly, if I consider intra assignment means here what happens? As soon as the d changes, immediately that value of the d will be saved in the temporary variable, and whenever the positive edge of the clock occurs, the data present in the temporary variable will be saved to q. Okay, so D will be evaluated immediately, but assignment will not be done. Assignment will be done only during this edge. Before occurring of this edge, even though if the value of D changes, it is not recognized, because first only its evaluation has been completed and stored in the temporary variable. So that is why even though after the storing the value in temporary variable, when the value of d changes, it is not considered. It will only assign the value which was computed previously, and that will be assigned during positive edge of the clock. Okay, this is how we are going to consider event based regular control. And next what we are having is named event control. Means for every event whichever we want to identify or whichever we want to create, for that we are going to give the name. Okay, in order to consider named event control, we are going to use the keyword event, and we are going to use the symbol hyphen greater than. So here this will going to give name for an event, and this will going to create the event, and this will going to identify when the event has been created. Okay, so for that we are going to use the keywords event and then this symbol and this symbol. So now let us consider an example. In this example, what we can observe is here I am giving name for a event which I want to create. So the name of the event is received data. So when an information is transmitting from one end to the another end, At the receiver end, I need to check whether the complete data has been received or not. So whenever a complete data has been received, then whatever the data till now it has received, it has to combine all that and then it should be given for the user. So that is why, in order to identify whether the received data is high or not, I'm going to create an event by the name received data. And then during every positive edge of the clock cycle, I will going to check whether all the packets has been received. So how to check whether all the packets have been received? I will be knowing usually what is the format of last data packet. So I'll be keep on checking during every clock cycle whether the last packet has been received or not. Whenever it receives, then this if statement will be active, because the condition will be true whenever it receives a last data packet. If this condition is true, then create the event. Okay, first I have given name, and for that name you create an event. So after creating a event, then based on this, we have to combine, isn't it? When we come to know that the last packet has been received, then all the packets has to be combined. So for that, we have to identify whether the event has created or not, isn't it? So for that, using this symbol, identify a event. How to identify? In the always statement, I'll going to check at received edge. So previously, let us assume that received data is equal to 0. And whenever an event occurs, the value of received data will change from 0 to 1. In such case, since an event has occurred, that's why the value has changed. So it will immediately observe and this statement will be executed. What this statement will do? It will combine all the data packets. Okay, this always statement will not be executed until it recognizes a event. Okay, when the event will occur, we have mentioned that only during this condition this event has to be created. So like this we can able to create an event using named event control. Okay, and the next one, when there are more signals has to be identified. When there are more signals has to be identified, in that case we have to use event or control. So that is why we are going to consider event or control. So what this event or will going to do means, I am going to check more than one signal. Okay, in the previous examples, we have observed that event occurring on only one signal is there, that is clock. But here we will going to consider event occurring on reset, clock, D. That is nothing but more than one variable we have to consider. In such case, either I can use or operator or I can use comma. Okay, if I mention the expression as always at, and here if I mention it as reset comma clock comma D. Okay, all this works as similar to this statement. Okay, so here more than one signals are considered, and in this signal either the event may occur on reset, or the event may occur on clock, or the event may occur on D, or event may occur on all the three at a time. Okay, means more than one or more than one event occurs, immediately this always statement will going to work. So that is why it is called as event or control. Or control means more than one signal we are considering. If only one signal is there means either I can go for this regular event or named event. But when I want to consider more than one signal, in such case I can go for event or control. Either I can use the keyword or I can use comma symbol. Okay, both will do the same work. And the last type of event control what we are having is one level based control. And yeah, before that, let me consider one more example. Here, what we have considered is using the symbol at and star. At will going to recognize the event, and what star will going to do? It will going to consider all the inputs uh, present in the expression. These in the statement, right hand side of the statement is considered as expression. When number of inputs present inside the block are more, in that case, remembering all the names in the sensitivity list will be difficult. Suppose if we miss any particular one or two names, in that case, even though if the change occurs, we may this always statement will not going to execute. For example, if you would have missed input C as well as H, okay, even though if the value of C changes, this statement has to execute. But since it is not sensitive for this, it will not going to execute. But what we will be expecting? We will be expecting that it is sensitive for all the inputs. So whenever all the inputs or more than one or more than one input changes, it will going to execute. But here what happens? We have forgotten that we have missed these two inputs. So as a result, we may not get the expected output. In order to avoid such type of errors, what we are going to do means, instead of mentioning all the variables, I'll just mention star symbol. So when I mention this asterisk symbol, what it will do? It will make the always statement sensitive for all the inputs present in the expression. So I need not necessary to remember the list. Simply I can use asterisk symbol. Okay, this is how we are going to consider the asterisk symbol when more number of symbols or inputs are there inside the always block. Okay, and the last one, now last type of timing control what we are having is level sensitive timing control. As I told, we will be waiting for a particular constant level, and whenever that level occurs, it has to be identified, and then the corresponding operation has to be done. So for that, we are going to use the keyword wait, and then to identify the first, I need to identify the change in the value. And after identifying the change in the value, then I want to recognize the level. Okay. So for that, we will be using the symbol at as well as at for change in the value, and for level wait. So here we can see that we are having always, in this example, we are having the keyword always, and then we are using the keyword wait. Okay. And here we are mentioning the expression. So what is this expression? Count underscore enable. It will be keep on waiting until the count underscore enable should become equal to logic high. Okay, when this value is high, because see, as I told, in case of if statement, if I mention if within parenthesis, if I mention it as reset, means it will always check for true condition, isn't it? And in Verilog, true condition is represented by logic 1. Similarly, here also it will wait for the true condition of count enable. When the true condition of count enable will happen? When the count enable value is greater than 0. Okay. So when the count enable is greater than 0 means it should be equal to 1. When it is equal to 1, then what it will do? It will execute this statement. In this statement, I have mentioned a delay. So it will wait for 20 time units, and then it will going to add count equals count plus 1, and that will be assigned to count. And afterwards, once again it will going to check whether this condition is true. If this condition is true, once again it will going to wait for 20 time units and then it will assign. Means as long as count underscore enable is high, the counter will be keep on incrementing. Whenever this becomes low, counter will not increment. Okay, it won't enter this statement itself. So this is how we can able to recognize a particular level. If I want to recognize logic 0 level, in that case what I have to do, I have to mention not of count enable. Not of count enable means it should be 0. Okay, this is how we are going to consider timing control in case of behavioral modeling.